Hi, this is Hema from 4th year CSC. Now I'm going to do my third experiment in data mining lab, which is K nearest neighbor based classification. In this, I have to build a K nearest neighbor model and then I have to use it to predict the class. So first I need a data set. I have iris data set over here. I'm just dragging and dropping it into the process tab. And the operator which I'm going to use here is cross validation. I'm just dragging and dropping it. Cross validation, it is also known as rotation estimation, and it is a validation technique for assessing how the results of the analysis will generalize the unknown data set. Now I'm making all the connections. I'm double clicking on this validation. Here I have two rounds. The first round is the training set and the second round is the testing set or validation set. First round involves partitioning a sample of data and performing the analysis. And in the second round, here we actually validate the analysis. The operator which I'm going to use in the first set, that is training set, is KNN, which is under the lazy learner. I'm just dragging and dropping it. KNN, the expansion form is K nearest neighbor. It is the simplest of all machine learning algorithms and it is used for classification and regression. Here the output of the KNN is a model that can be applied to the unknown data set, and the input of the KNN is the training set. The parameters of KNN are the value of K. Here I can denote the value of K. I'm just giving it as 3, and I have a checkbox called weighted oath. If this parameter is set, the weight of the examples are also taken into account. And then I'm moving into the testing set, which is the second round. The operator which I'm going to use here is apply model. I'm just dragging and dropping it. Apply model operator, it has two inputs. One is our model and next one is the test set. And it returns a labeled data set, which is our input data with some additional special attributes. Example, prediction and confidence. The next operator which I'm going to use is performance. Based on classification, I'm just dragging and dropping it over here. Performance operator, it needs this attribute to measure the performance of the model applied on your test set. So I'm connecting the apply model with the performance, and the output of the performance is the performance vector. So I'm connecting it to the result. Now I have made all the connections in the validation and in the total of process. Now we'll see the result. This is the output of K nearest neighbor based classification. In this, in the iris dataset, actually we have three classes, namely iris setosa, versicolor and virginica. Here the class precision are also shown. It is 100%, 94 and 94. Here the error percentage is much lesser than the expected one. Actually it ranges between 90 to 100 So this is okay with us. And in the output we can also see what is the iris data and KNN classification. Actually we have given the number for K as 3. So K nearest neighbor for model for classification, and this we have the following classes: Setosa versicolor and virginica. We can also see the plot view. Here it shows how it is plotted. Like in the x-axis they have said about the true class, and in the y-axis the predicted one, and in the z-axis the counters of. That's all about the experiment. Thank you for listening.